Okay, hi all. My name is Tim Hinrichs, and in this session, we're going to be covering an introduction to the Open Policy Agent project. First of all, I thought we'd start off with a little bit about me. My name is Tim Hinrichs. Like I said, I am the co-founder and CTO at Styra. I'm also one of the co-creators of the Open Policy Agent project. Feel free to go ahead and hit me up with questions, either on Slack or Twitter, wherever you can get a hold of me. So when we started OPA, we really realized that there was a very clear problem out in the world, and that was that there were all kinds of different pieces of software that you see shown on this slide, and all those different pieces of software in the cloud native ecosystem had their own way of solving the policy problem. So anytime someone tried to deploy a resource onto Kubernetes, there's a policy or an authorization problem that needs to be decided on. Every time an API call gets made on a microservice, there's an authorization problem that needs to be solved. Every time a person or a machine runs a query on a database or on Kafka or any other sort of messaging system, there's a policy, an authorization problem that needs to be solved. Every time somebody tries to spin up or update or delete resources on the public cloud, there's an authorization problem that needs to be solved. Every time someone tries to SSH to a Linux server or spin up a Docker container, there's an authorization problem that needs to be solved. And the same is true of CI/CD. Anytime someone's trying to merge code or deploy resources through a CI/CD pipeline, an authorization policy problem needs to be solved. The challenge here is that each and every one of these different pieces of software have their own way of solving that policy, that authorization problem. And what that means from a user's point of view is that even though I am perhaps tasked, I'm handed an email or a wiki or a PDF that describes in English what the authorization policy should be for one or many of these different pieces of software, I need to learn a different API, a different GUI, a different even model for thinking about how you enforce authorization policies across all of these different technologies. And so when we started OPA, we said, well, that's not a great state of affairs. What would be great is if we had a unified way of enforcing authorization and more generally policy across all of these different cloud native pieces of software. And so that's what we designed OPA to do, is provide that unified policy solution. In particular, the way we talk about OPA is that it is a general purpose policy engine, which means that you can use it to make policy decisions for all the different pieces of software that you see here on this slide. Now, I'll go into this a little bit in a bit more detail later, but for now, keep in mind that a couple of the most popular use cases for OPA are shown here on the slide. In fact, all of the use cases here for OPA are used by someone in production today. So this is not a theoretical exercise in enumerating potential use cases for OPA. Rather, these are production use cases for OPA today. So one of the most popular, and we'll talk more about it later, is this Kubernetes admission control use case. So every time a user, whether it's a person or a machine, tries to create, update, or delete a resource on Kubernetes, OPA is often used to make a decision as to whether or not that resource is safe to deploy. Similarly, in the microservice category, every time a microservice receives an API call, it's got to decide, is this authorized or not? That's another very popular use case for OPA. Now, one of the things that we'll get into a little bit later is that architecturally, the way that you think about OPA is that it really is designed to run, sort of as shown here in this picture. It's designed to run on the same server as whatever software needs authorization decisions. So in the Kubernetes use case, that would mean you'd run a handful of OPAs on each and every Kubernetes cluster. In the microservice use case, that would mean that you would run one OPA on the same server as each and every microservice that you have running. So if you have 500 instances of microservices, you will likely end up with 500 instances of OPA. And the reason that we do that, the reason OPA was designed architecturally that way, is to provide high availability and high performance. Nearly the same availability and performance that you would get if you left the policy like hard-coded into that microservice or into that Kubernetes cluster. But obviously, OPA's job is to decouple policy, to pull policy out of that microservice or out of that Kubernetes cluster, so that you can manage it separately. You have a unified tool set to manage policy and to write policy. All right. Now, we do on the Opa website, if you're looking for different integrations, have an integration index. So definitely check that out and let us know if there are things that are missing or things that you'd like to see there. Opa is a completely, if you don't know this already, a completely open source cloud native computing foundation project. Every single line of code that's ever been written for Opa has been done in a public GitHub repository. We founded it at Styra back in 2016. We donated it to the CNCF in 2018, about 2 years later. And about a year after that, in 2019, it became an incubating project. The DevStats tool, which is really handy from the CNCF, says that at the time I looked at this up last, there were 30 plus companies contributing and over 100 developers. If you want to check out some of the contributors, just like every CNCF project, Opa does have a contribution guide, and I should say an adopters list as well. To get a sense as to some of the other users, it's always great to hear how users are actually using Opa. I would definitely point you to the KubeCon US back in 2019. There were a bunch of sessions in the standard KubeCon track. You see those listed here. But what I'll also call your attention to is the Opa Summit. So this was about a half day where we had a bunch of users from Opa come and talk about how they were using it. And this covered a bunch of the different use cases: the application use case, Kubernetes use case, microservices, Kafka. And I think those were the most of them. But definitely check those out. There are definitely good lists of these sessions that you can find. Now, okay, what is Opa exactly? I mentioned it a little bit ago that it's a general purpose policy engine, but what does that mean really? Well, so the way that Opa works is pretty much the same for all of those different use cases, for all those different software systems we saw in the last couple of slides, in terms of how that software system works with Opa. So that what we know is that we start with some service. That service could be the Kubernetes API server, it could be a microservice or a network proxy, a service mesh, a database, it doesn't really matter. That service at some point in its life cycle decides that it needs a policy or an authorization decision. And so it sends a policy query over to Opa. Opa's job is to return a policy decision quickly to that service. It is the service's responsibility to enforce that policy. It is Opa's responsibility to make that policy decision. And so that's how that separation of responsibility really lies. Now, there are a couple of important things about that fairly simple interaction, one of which is the policy query that the service hands over to Opa. This policy query, as it's noted here, can really be any JSON value. So in an HTTP API authorization use case, that service might send over a user, a method, and a path. In the Kubernetes example, the service, a Kubernetes API server, might hand over 100 or 200 or 500 lines of YAML or JSON that represents whatever pod, ingress, or whatever other resource the user's trying to create on the cluster. So in both those cases, what Opa sees is just some JSON data that comes across. And it's Opa's responsibility to make the decision. The fact that the policy query is itself just JSON data, it's not something that Opa understands what in the real world that JSON data represents, is why Opa can be used so easily across all of these different use cases. So Opa has not one line of code about what a Kubernetes pod or an ingress means, or an HTTP method, or a Kafka queue. None of those are things that Opa itself knows about. So then the question becomes, how does this all work? Well, when I, as a person, am writing a policy, I know what a HTTP method, a path, and a user represent in the real world. I know what a Kubernetes pod or a Kubernetes ingress or a Kafka queue mean in the real world. And so I, as a policy author, can go ahead and write whatever policy is correct for making this decision. And so it is really a contract between the service and the policy author that at the end of the day assigns a semantics to that policy query that's handed from the service to Opa. All right, so that's one thing that a lot of people like about Opa, is that they get to be really creative about how they do integrations between the service and Opa, because as long as they can take some JSON data and hand it over to Opa, then they can ask Opa for a policy decision. What that means, though, is that there's quite a bit of reliance on the policy language to be quite flexible and powerful in terms of the kinds of policies that it can write and express. So that Rego is what we call Opa's policy language. Rego was designed to be good at processing and making policy decisions about arbitrary JSON data. In particular, there are three things I like to call out about what Rego allows you to do. The first of which is, or maybe I should say, all of which are easily exemplified if we think about the kinds of policies that you need to write in the Kubernetes use case. So in the Kubernetes use case, imagine that the API server is handed over to Opa 100 or 200 lines of JSON representing, let's say, a new pod that a user is trying to create. Well, in order to write policy, and let's say the concrete policy we want to write ensures that all images in that pod come from a trusted registry. All right. Now, in order to write that policy, within the Rego language, you need to be able to dig down through that deeply nested JSON data that represents a pod. You need to be able to find that containers array. You need to be able to iterate over all the elements of the containers array, and for each one, extract the image field. And then for that image field, you need to be able to check whether or not that image name comes from a trusted registry or not through some kind of string manipulation. So all of that functionality is functionality that's built into Rego and that Rego handles pretty easily. And so that's another thing that a lot of people end up using pretty heavily, obviously with Opa, is that rich, flexible policy language that allows them to write policy over arbitrary JSON. The third thing I'll call out about this picture is that on the right-hand side, there's that data in that JSON. The other input that Opa uses in order to make a policy decision, besides the policy, the Rego itself, is this, what we like to call external data. So one of the things that Opa was designed for from the beginning was to enable people to write what we like to call context-aware policies. So context-aware policies to us just mean policies that are aware of the world in which they're being evaluated. My favorite example here is, let's imagine that you wanted to write a policy that allowed only people who are on call to make changes to a production Kubernetes cluster, to query production databases, and to SSH into production servers. Well, who's on call? Kubernetes doesn't know, the servers don't know, the databases don't know who's on call. Even the identity store, whether it's Active Directory or LDAP or whoever your identity provider is, they don't know either. So who's on call is usually information that's stored in a third party like PagerDuty. And so what you can do with Opa allows you to inject arbitrary external data into it so that you can write policies using that data. So in this case, what you could do is you could pull that data out of PagerDuty, inject it, that list of who is on call, into Opa. And now it just looks like more JSON data to Opa. And so as a policy author, now you can go ahead and write exactly that policy that ensures that only on-call people have those elevated rights. All right, so that's another thing that people really like about Opa, is being able to inject arbitrary data to make decisions. The last thing that I'll call out here is this policy decision. There's a note here that says that policy decision can be any arbitrary JSON value. And this speaks to the fact that Opa is a general purpose policy engine, meaning that yes, you can, and many people do use Opa to make authorization decisions, meaning allow, deny, Boolean, true, false, 1 or 0 decisions. But you can also use Opa to make policy decisions that are far richer than that. You could use Opa to write a policy that makes a decision, which is a rate limit, returning a number. You could return, you could write a policy that ensures that says which clusters to deploy an application to. For that, the answer might be an array of strings. You can even have Opa make policy decisions that are represented by arbitrarily deeply structured JSON objects. And in fact, that kind of return value is often quite useful, because in addition to maybe, even in the authorization setting, in addition to just returning allow or deny, you might also want to return, let's say, an array of error messages to send to the user. So that hopefully gives you a good sense as to what Opa is capable of doing and how it interacts with and how it integrates with all of these external systems in order to make policy decisions. And at the end of the day, Opa's job is to decouple those policies from the underlying service so that you can manage them all in a single language and use a single tool set across all of them. Let's look at a couple of concrete examples quickly. So one of which is one of the most popular applications of Opa, and that is microservice API authorization. So the way this works is pictured here. What we have here on the right-hand side is really this microservice. And one of the common questions that we get is, well, do I have to modify my microservice to talk to Opa? And in this picture, we show quite clearly that the answer to that is no. The answer to that is no if you use a network proxy, which is what we often see people do when they're using OPA for microservice API authorization. The idea behind the network proxy integration is that you use a network proxy like Envoy, Linkerd, Kong, Apigee, or any of the others that you might care to use. And you run that network proxy on the same server as that microservice and route all network traffic through that network proxy. Then what you do is you integrate OPA with the network proxy so that each and every time a request comes in to the network proxy intended to go to the microservice, the network proxy can send that request over to OPA, ask, is this authorized or not? If OPA responds and says, yes, that's authorized, then the network proxy can go ahead and forward it to the microservice as usual. But if OPA says that that API call is not authorized, the network proxy can return a 403, drop it, do whatever you've configured the proxy to do. So this is pretty much a network proxy integration. We see this being used pretty often. And as you see, it matches pretty closely with the description that we had on the last slide. Let's look at another example integration. This time it's with the Kubernetes API Server. The popular integration here is using OPA to make policy decisions about as part of the admission control process that Kubernetes supports natively. So the way this works is that each and every time a user tries to each and every time the user tries to make a change to the resources running on a Kubernetes cluster, that request goes through the Kube API server, and the Kube API server has a whole pipeline of changes of checks that it goes through. The first of which is authentication, who are you? The second of which is authorization. This would be basically RBAC. So, you know, if it's me trying to make the change, then is Tim authorized to create a pod at all on this cluster or not? Once it makes it through authorization and RBAC, then it goes to admission control. Admission control is run on every create, update, and delete. And what happens is that this admission control hands over that entire 100, 200 lines of JSON or YAML that describes that new pod or that new ingress or that updated pod or ingress. And it sends that entire chunk of JSON over to OPA and asks OPA for a decision. Is this resource safe or not? The nice thing about this particular integration, and that integration works the same way we've gone through. The nice thing about this integration, and the same is true of the last integration, is that it is a native integration. So there's no way to circumvent the API server with Kubernetes, and therefore there's no way to circumvent the OPA checks that are put in place here either. So that's pretty powerful. This use case has become so popular, in fact, that it has a dedicated sub-project called Opa Gatekeeper. I definitely recommend you check this out if you're looking to put policies in place for admission control. The third use case that we'll go through briefly is in the CI/CD pipeline. Here, the idea is that you've got pipelines set up, and what you can do is use OPA to test those configuration files, those YAML files, or those INI files in the pipeline before they get merged. And so this is a pretty powerful use case as well. Again, the integration with OPA works just the same as all the others. And so this use case has become so popular as well that there's now also a dedicated sub-project to it called Opa Conftest. So if you're interested in running policies over configuration files, either in a CI/CD pipeline or maybe even on developer laptops, I also recommend you check this one out. All right, so we've gone over how you integrate OPA and kind of what OPA is. Well, what other features does OPA have? That's what we're going to cover here. So the first of which we've already talked about, it does have that declarative policy language that is quite powerful. We've already also talked about a couple of the language features. I didn't mention this yet, but OPA does have over 50 built-in functions. Those built-in functions allow you to do things like string manipulation, time of day, JSON web token manipulation. You can verify and decode JOTs right there in the OPA policies. You can do CEDAR arithmetic as well. We've already talked about context-aware policies, a PagerDuty example. There's also composition and delegation. One of the nice things about OPA was that the language was designed to allow you to break your policies up into one or more modules. Each module, just think of it as a namespace, like you would in a traditional programming language. But what that also allows you to do is also delegate decisions to different policies based on whatever conditions you care care about. So the example I always use is, imagine you had a compute team writes a policy for compute resources. You have a networking team writing a policy for networking resources. Then anytime a request comes in, you can write a third policy that looks at that request and says, well, is this a compute resource or a networking resource? If it's a compute resource, delegate the decision to the compute policy. If it's a networking resource, delegate the decision to the networking policy. If it's actually a resource that has a bit of both, well, then maybe you require both the compute and the networking policies to allow the request before you allow it at all. So that's composition and delegation. Another important thing about Opa is that it was designed to take as much of the burden for performance away from the policy author as possible. So what that means is we like people to think about, to the extent we can make this happen, that we want people as policy authors to think about writing correct and maintainable policies. And then, as much as we can, we want to push the burden of performance off to Opa. To that end, there are a couple of pretty powerful optimizations that we have in place, one of which is rule indexing. What this does is it statically analyzes all the rules you've written. It constructs a trie to organize those rules so that when a new request comes into Opa, Opa can very quickly walk the trie and find the fragment of rules that it actually needs to evaluate in order to answer the incoming query. Partial evaluation, I like to think of this as a compiler technique that evaluates as much of the policy at compile time as it can. Again, leaving the amount of work that it needs to do for evaluation at runtime to the minimal extent possible. In terms of architecture, I've already mentioned that Opa was designed to be effectively a host local cache of any policy and data that it needs in order to make decisions. So what we see most people doing is running Opa as a sidecar or a host level daemon. You can also run Opa as a Go library if you like. One of the important things, though, that we decided early on was that Opa is not intended to be a source of truth for policy or for data. It is a cache. All the policy and memory are kept, all the policy and data are kept in memory. And one of the nice things, therefore, is that there are 0 decision time dependencies. Opa always has whatever policy and data it needs in order to make decisions without having to jump off the server. What that does, though, is beg the question, well, how do you get policies into Opa, from the source of truth into Opa? Opa does provide a number of what we call management APIs for control and observability. So the bundle API allows you to configure Opa to download policies from some source of truth. The status API allows Opa to periodically upload how it's doing up to some third-party service. The logging service allows Opa to record each and every decision that it makes, again, to some centralized service. And there, in particular, I'll mention that the logs that are recorded are not just text files. They are what I like to call high fidelity JSON logs. So the inputs that Opa received, the output it received, all of that is stored in JSON. And so you've got quite a bit of information to work with there. It's great for audit. And then finally, there's a discovery API. That discovery API allows you to dynamically configure the bundle, the status, and the log all at runtime. In addition to management APIs, Opa does come with a bunch of tooling, a lot of the same tooling that you would expect from a traditional programming language. So here, in particular, there's a unit test framework. We highly recommend you write unit tests to make sure your policies are correct before you deploy them. Dependency analysis, a formatter, Opa checker. There's a VS Code plugin as well. There's a tracer. There's a profiler when you start looking at performance. There's also a playground. If you have not checked out the playground, it's a great place to write some policy, evaluate it. There are a number of well-documented examples there to get you started. And then it also implements the bundle service. So you can also hook up your Opa and just to try out how everything works together. You can run your Opa on your laptop or wherever you want and have it download policies from the playground. It's a great way to get a feel for how that would work end to end. Stepping back, the way I like to think about Opa is that what it really embodies is policy as code. And just like we have a software development lifecycle, Opa and all of its tooling enables a policy development lifecycle, a whole collection of activities that need to happen in order to safely and securely build and enforce and monitor the policies that are important throughout an organization. So the requirements gathering there on the left-hand side, that's obviously not really something OPA can help with, but it's an important part of the policy development lifecycle. Policy authoring, obviously there, how do you write policies? You need to version control them and so on. There's a CI step where you want to test policies. I already mentioned the OPA test framework. There's also a build step where you can build those bundles and you know, assemble those policies from wherever their sources of truth actually are. Deployment, you need to deploy those policies to OPA and make sure that it's always got whatever policies it needs to make decisions. Monitoring all of the OPAs, logging all the decisions that OPA makes. So all of those headings should sound very familiar to anyone who's working in software development. Those same kinds of activities are the things that the OPA, and all of its tooling enables, but for policy. That is all for today. So thank you so much for giving me your time. Hopefully you found this informative. Definitely check us out online and feel free to send us questions whenever you have them. Thanks so much.